Hi, I'm Karen Chung.
And I'm Jason Hill.
We're here to walk you through the Xpert Protection Manager software. Xpert Protection Manager is a free Windows-based tool that you can use to better manage, configure, test, and troubleshoot circuit breakers equipped with Xpert Release (PXR) electronic trip units. We will refer to Xpert Protection Manager as PXPM throughout this training. This training will take you through the different parts of the PXPM software and walk you through the included features. Then we'll show you licensed apps that you can purchase to extend your functionality and get more out of your breakers.
PXPM can be downloaded free at eaton.com/pxpm. This link also includes the latest quick start guides, installer files for the software, and useful information. For this training, please download and install the software to your PC so you can follow along.
In this video, we will be using version 3.2.4 of the PXPM software with a Power Defense PDG3 molded case circuit breaker. The available features set may vary slightly by breaker family, options, and frame size, but the majority of what is shown should still apply. We are always improving our software and adding features, so if you have a newer version, your copy may be a little bit different than what you see today. However, much of this information will still be applicable regardless of which version you have. When you first open up the PXPM software, you'll be taken to the home screen.
You will see that most buttons are grayed out. This is not because you have to pay for them. It's because we don't have a breaker connected to PXPM. Please see where it says Connect. Notice that there is nothing connected right there. We will take a look at how to fix that.
To connect PXPM to a compatible breaker, you'll need a standard USB micro data cable. Sometimes these cables are referred to as charge and sync cables. Plug one end of the cable into the USB port on the front of your breaker and the other end into a USB port on your PC. PXPM will recognize that your breaker is now connected, and all of the buttons will now be active. You can see that the Connect drop-down now shows a device.
If for some reason you had multiple devices connected at the same time, you could toggle between the devices with this drop-down. We don't recommend this from a practical standpoint, but it can be done. Now that you've connected to PXPM, you can manage your breaker's configuration by using PXPM and making changes directly to your trip unit's set points. If you don't have a breaker handy, you can also create a parameter file or edit one that was created previously to export to your breaker later. You can manage other breaker settings in device settings, such as changing the device's date and time, updating the password, downloading a different language to the breaker, or even resetting the device.
PXPM has a test mode that allows you to exercise the functionality of the breaker through the software. From here, you can open your breaker and verify its functionality without a test kit using our free Open Breaker Test. If you're looking for something a little more extensive, a license for the Advanced Testing app will allow you to perform secondary injection testing, simulated testing, and to verify your current sensor continuity. We will elaborate more on that topic in the test mode section of this training.
If you're looking for your breaker serial number or manufacturing date, you can find this information on the breaker information screen. You can export this information, along with any other breaker installation details you'd like to add, to the cover sheet with the Export PDF button.
The real-time data screen allows you to dive into what's currently happening with your breaker. Aside from the real-time metering data, current voltage, energy, etc., we can also view mins and maxes since the last reset, and energy demand. You can even perform a single cycle waveform capture. Breaker status and breaker health are available from this screen as well.
The event summary screen will allow you to access detailed information of recent trip events or alarm events. You can also see a timeline of older events. We have a report screen where you can configure and customize your PDF reports.
And last but not least, you have the application settings screen where you can license apps, change the language of PXPM, or find your version number. You can find your version number under Application Settings and About. Your tech support contact info can be found in the table below. And if you want to update your software for the latest features, visit eaton.com/pxpm.
Let's take a look at the Setpoint configuration screens. In this example, we'll be using a power defense molded case circuit breaker, but other breaker families will be similar.
If you're in front of the device, you can select Connect to Unit. You will see some basic info about the breaker pre-populated, like frame size and current rating, and what type of trip unit you are connected to, as well as other features the trip unit would have. You can make updates to your set points from this screen. Protection settings such as LSIG and thermal memory, and unit settings such as communication protocols and settings for power and demand, programmable relays, LCD text orientation, breaker health alarms, and many others can be adjusted here. For instance, you could disable ground fault for secondary injection testing, as you'll see later in this testing video.
Only features that are present and enabled will be able to be configured. For instance, you will need to enable short delay protection to change your short delay pickup. As you make changes, the trip curve in the lower right will update to reflect them. If you want a closer view of your trip curve, you can look at each piece, L, S, I, and G, by navigating with the tabs. The Full View button pulls the curves into a larger window for a closer view.
One thing to keep in mind, if you have a breaker with setting dials on the front of the trip unit that control specific set points, you cannot use PXPM software to change these set points. You can only make changes by using the dials on the front of the trip unit.
You can see all the changes you have made in the change summary. Pending changes are in orange. When you're happy with your changes, export them to the breaker. As you do so, you will be prompted to create a backup of the existing set points before you write over them. It is important to always create a backup just to be safe, because you may want to undo the changes you exported to the breaker. Since this is just a demo, I'm going to choose no. I'll put in my password, which I have kept as 0000, the default.
It's always a good idea to change your passwords. There is a section on changing passwords later in the demo.
Now that I've pushed the changes to the breaker, they turn green in the change summary. I can continue making changes, which will show up in orange, until I export them to the breaker. Nothing will change in your breaker until you hit export. If you've made some changes and don't want to export them to the breaker, you can use the Undo Changes button to revert any set points that you've changed on screen but have not yet exported to the breaker. If you want to undo the changes that you've already exported, that's where your backup file comes into play. If you did not back up your file, like I didn't in this tutorial, your original values are listed here. So if you're in a pinch, you can go and put things back manually. If you want to do that, it's very important that you don't hit refresh. Hitting refresh refreshes this screen and pulls what is currently on the breaker, almost as if you started a brand new configuration session. You may also like what you have here, and you may want to use these set points on other breakers. The Save As button will allow you to download these set points into a file that you can share with someone else, or use on another breaker with the same rating and configurable options. If you try to use a frame 2 parameter file on a frame 6 breaker, you'll get an error. There's an easy way to create a file for a different breaker configuration, and we'll show you that in a minute.
But before jumping into that, I'll point out the PDF report button. Notice the pop-up. That's for the cover page, and you can optionally choose to customize with your information. Let's go ahead and view report, save it off. The set point report shows each of the settings before and after. We actually call them as found and as left. If you made any changes, then these won't match and these changes will be highlighted. If you want to create a setpoint file, but don't have a breaker handy, you can go back to the Setpoint configuration menu and create a setpoint file with new offline settings. Choose your device type. In this case, I'll pick Power Defense MCCB. Hit OK.
This takes us to a screen very much like the one we were at before. The biggest difference is that you must select the features that you expect to be in the trip unit to be programmed, whereas before they were pre-selected.
It's worth mentioning that if you have a breaker that doesn't support a function like Modbus or ZSI, you can't turn it on through PXPM. Selecting yes here in your parameter file isn't going to help you. It's just going to give you an error we talked about when you try to export the file to your breaker later. Basically, the idea here is that things need to match, but otherwise pretty straightforward. Same undo, same save and PDF. Export is different. If you're actually offline, like this tool is intended, it'll take you to a connect to breaker so it has something to export to. If you change your mind and plug in the breaker halfway, you can export no problem. What if I already have settings file and I want to make changes to it?
If you go back to the Configure Setpoints menu, there's an option to Open Settings. Click on Browse to navigate to the Setpoints file you saved. Then you click Next. You end up back in the offline editor you were in previously. Same deal, make your changes and save as.
What do I actually do with all these Setpoint files?
Let's say you've only got a limited amount of time to access the breakers you want to configure. You could do all the configuration work without a breaker before you even set foot on site. Then, once you arrive, programming the breakers is easy. Unable to make it to the actual site? Create the correct offline configuration and send the file to an electrician or maintenance person at the facility. Here's how you do it.
Back at the Configure Setpoints menu, the final option is Export to Unit. Browse for a file and click Next. If the breaker rating and the trip unit style of the file don't match the breaker you are connected to, you'll get an error and you won't be able to proceed. But if they're a match, you'll be prompted to save a backup of the current setpoints before you overwrite them with your new file.
Now go to the Device Settings button. You can reset your trip unit from the Device Settings menu under the Reset Trip Unit button.
Got an LED that's stuck on after trip?
You turn the breaker off and back on again, but you will have to acknowledge it in the software or on the unit. This helps to make sure that the fault has been reviewed by the maintenance department or electrician without causing any more downtime.
Want to start accumulating your energy from zero? Reset it. Need to start over with your mins and maxes? Reset it.
Aside from LEDs and metering data, you can also reset your diagnostic data, though this is typically not recommended unless you have a specific reason for it.
Why don't we want to reset the diagnostic data in our breaker?
Every breaker operation, every overload, every fault puts somewhere on your breaker. Depending on the specific conditions present during each, every event has a different impact on the overall life of your breaker. The PXR electronic trip units have a unique feature called breaker health. Breaker health captures the impact of these events over the life of the breaker and uses an intelligent operation to predict how much more effective life it has remaining. This helps with proactive maintenance and resource planning. By resetting the diagnostic data, you're deleting the breaker memory of the various faults that occurred throughout its life. Not only do you lose all the history, your breaker health will appear artificially high. Resetting the diagnostic data will not extend the life of your breaker. It will give you an inability to monitor it. So don't reset the diagnostic data unless you have specific guidance from your user manual. You can also set your trip unit's date and time by selecting the date and time. You can set this manually by using the date picker and the clock, or you can have the trip unit use your PC's time by choosing Select System Date Time.
That doesn't mean that it's going to stay synced, though.
No, that's just for right now. It'll pull the current time when I hit Update. If your breaker trips and there's no aux power, the battery is dead, then your breaker might lose its time. But don't worry, all breaker protections will still work with or without the battery.
What about all my data?
That'll be safe too. The only thing you lose is your timestamp. That and the cause of trip LED won't flash until you replace the battery or bring in some other power source.
But what if I want to replace my battery?
It's a pretty common watch battery, a CR1216. You can pick one up at your local drugstore while you're waiting for the ones you've ordered online to arrive. Let's say you want to change your circuit breaker password. There's a password screen on the device settings menu. From there, you can verify your password. If you enter an incorrect password, you'll get a warning. Be careful, you only get 5 chances to get it right before the software closes. Let's try that again. In this case, my breaker is still using the factory default password. That's not very secure, and it's not recommended. So let's go ahead and change it. Just like any other password change screen, enter your old password, enter your new password twice, then hit OK. In this section, we'll cover how to change language of your trip unit. To change language on the PXPM software, please see the Application Settings section.
Here's how you change the language of your trip unit. First, you need your language file.
Power defense breakers ship from the factory with English and Chinese on them by default. However, you can download up to 4 languages. Additional languages can be found at eaton.com/ PXPM.
Once you have your language file, select Download Language from the Device Settings menu. Select your language file and download.
What if I run out of slots and I want to replace a language that's already there?
Select the language to delete it. Depending on which breaker you have, there will be default languages that you can't delete. You also can't delete the language that you are currently implemented.
PXPM is an incredibly powerful tool for circuit breaker testing. From basic breaker opening verification to more advanced testing, PXPM can do it all. All you need is a USB microcable. Let's start with open breaker testing. This allows you to verify the mechanical functionality of your breaker. This ensures that the trip unit can receive the command and can operate the trip actuator to open or trip the breaker. To perform this test, select Open Breaker and then Test. You will be prompted for your password. The breaker will open and the completion of the test will be reported. At this point, you can continue testing or stop. Let's continue testing. This takes us back to the testing screen. The rest of the testing functionality is available with the Advanced Testing app.
How do I get the Advanced Testing app?
Keep watching or jump down to the licensing section of this program. Let's start by demonstrating how to use it. Electronic circuit breakers can be complicated. Electronic circuit breakers can do much more than their thermomagnetic predecessors. Like any great team, all the parts need to work together in unison. Normally, when a circuit breaker is in operation, we have current passing through the current sensor. This sensor interfaces with our PXR trip unit and all the circuitry there. Think of it as the PXR trip unit being the brains of the breaker. The trip unit is controlled by its firmware, which uses the set points you've programmed and the trip curve to execute on the protection algorithms. This is how a breaker knows to trip on long delay, short delay, instantaneous, or ground. If it is time to trip, a signal is sent to the trip actuator.
That's what does the actual tripping when your breaker sees too much current.
All of these pieces have to work together in order to have the breaker function properly.
When we did open breaker testing earlier, that was just this piece here, the trip actuation mechanism. You verified that your breaker is good from this point on. We hear people talk about primary injection testing and secondary injection testing. Can you explain?
Previously, the only way to test all the pieces of the circuit breaker was to run the current through the main terminals of the breaker and actually trip it. This is a lengthy process. You have to power down the gear, remove the breaker, set it up with an expensive test kit, test the breaker, and put all the pieces back together. The process is intensive, costly, and actually puts unnecessary wear on the breaker contacts. Also, when you reconnect the breaker, you have to make sure the line and load connections are secure and torqued correctly. Since primary injection is so labor-intensive, secondary injection has become a more common test for electronic circuit breakers. Typical secondary injection testing skips the current sensor. There are test kits that inject current directly into the breaker's secondary, also considered the low side of the circuit. You still test most of this breaker this way, and it's a little more manageable. With PXPM and a USB microcable and the Advanced Testing app, you can test your circuit breaker as completely as a primary injection test, without the wear on the breaker, the heavy and expensive test kit, or all the hassle of taking everything apart. Simulated testing is part of the Advanced Testing app that can be licensed to enhance PXPM. The Advanced Testing license unlocks this feature. A simulated test is, instead of interacting with a physical part of the trip unit, we're going to test the LSIG protection algorithms. Basically, we're testing this piece right here. We're having PXPM tell the trip unit to pretend it saw a given current. This is a good way to verify that your trip unit is functional and to quickly check various points along the time current curve. If your breaker is connected to a PLC or an operator interface, you can use this test to quickly see the status change or verify the communications are formatted correctly between the two.
Now let's show how a simulated test is done.
Select Functional Test and then select Simulated. From here, you can verify LSI or G. If you choose long, short, or instantaneous, you'll need to select either a phase or neutral. You can also choose to verify in maintenance mode as well. Set your desired current and then decide if you want your breaker to trip as part of the test. Since we already did the open breaker test earlier, we can choose no trip here, since we've already verified the breaker's mechanical functionality. You might get a caution message or a warning message if there's a setting in your breaker that will prevent the test from executing as planned. For instance, here it says that our ground fault protection is set to alarm or trip, and the sensing type is residual. This will make it trip on ground fault instead of LS or I. So we'll want to turn that off on the long delay. We can do that from the screen by selecting Change Device Settings, which will take you back to the Setpoint configuration screen.
You can change your set points as shown in the Setpoint configuration part of this video. Save and export to the device.
Now you can test. After the test, you will see whether or not the test passed and what that looks like with respect to the time current curve. A log of other tests from this section are also listed down below. If you're finished, stop testing. You can generate the test report or adjust your device settings and exit. Now that we've tested the LSIG protection and the trip mechanism, let's verify that the electronics are working correctly. We're going to inject a variable current into the breaker secondary and try to trip the breaker. Every PXR trip unit has a special circuit built in. PXPM sends a command to this circuit to generate a signal that looks like the expected output of the current sensor. If this test passes, your breaker will be good from here to here. This test is better than a secondary injection test kit. From the breaker test screen, select Functional Test, Secondary Injection. From here, just like before, choose Long, Short, Instantaneous, or Ground Test. If you select LS or I, you'll need to select the appropriate phase. Also select Trip or No Trip.
Maintenance mode enables Eaton's Arc Flash Reduction Maintenance System, also referred to as ARMS. For more information on this, visit the Molded Case Circuit Breaker page within eaton.com/powerdefense, where you'll find white papers on the subject.
As before, you'll be notified if your current set points will cause an issue during testing. Change the set points here. One other tip, if you're going to perform a lot of testing, it might be good to turn thermal memory off. If you understand the concept of thermal memory, and you're comfortable deciding whether it should be turned on or off, feel free to skip ahead. In the early 20th century, trip units were purely mechanical devices. They didn't have electronics in them. The first trip units were just a piece of metal, called a bimetal, which would bend over when the current passing through it would heat the metal. Eventually, the trip unit would push the trip bar and open the breaker.
Eaton still offers thermomagnetic circuit breakers, available in the power defense line.
That's correct. Although thermomagnetic cannot perform any of the sophisticated functionality that has been discussed in this video. Beginning in the 1970s, electronic trip units became state-of-the-art technology. Though they offered more precise trip curves, there was one problem. Thermomagnetic trip units have simple protection features that people expect from their circuit breakers. For example, like getting warm when the breaker trips. If the breaker trips a lot in a short amount of time, they get really warm and stay warm. The physical properties of the trip unit mimic the thermal heating of the load cables and makes the breaker trip faster. It's almost like they remember the heating in the cable and that they tripped recently, hence the term thermal memory. The downside is this. Suppose you're sending equipment to the middle of the desert. The thermal protection bimetal element might already be bending over because of the high ambient temperatures. These breakers need special calibration to operate in that environment.
Will it always trip faster?
No, a thermomagnetic breaker does that until it cools down. That's actually a good thing, most of the time. It protects the cables and the devices you have downstream because if you're continually overloading and tripping your breaker, that's probably a load or system fault that needs to be corrected before the insulation on the cables gets so hot they start to melt. Here's the problem though. Electronic trip units normally don't behave that way. After an electronic unit trips and opens the breaker, the trip unit may lose power and forget that it was overloaded. And the cables are hot. Eaton's PXR electronic trip unit, unlike some competitors, is designed for continuous overload and overheating protection. The trip unit does not need power for thermal memory, so it is functioning like its thermomagnetic counterpart. If you're planning on doing a lot of tests on the same breaker, this protection feature can affect the testing results. It starts to skew your test results by making your breaker trip faster because it thinks it's protecting your cable and your downstream equipment. But if you're just testing, it may make sense to turn it off during the testing. I'm going to go ahead and turn thermal memory off. When you run your secondary injection test, you get a similar results screen as you had in your simulation test. If you're finished, stop testing. You can generate a test report or adjust your device settings and exit. Don't forget to turn your thermal memory back on now that you're finished. So we've proven that your breaker is good from the trip actuation up through the input circuitry.
The piece that's missing is right here with the current sensors.
There's a way to test that too. This test is only available if your breaker has embedded Rogowski-style sensors. Some breakers use iron core CT, so the test is not available. Please consult your breaker manual or catalog for more information. Let's set this test up. From the breaker test screen, select Current Sensor Test. Clear any warnings and choose Test. Once PXPM finishes, the completion of the test will be reported. At this point, you can continue testing or stop.
We've tested the entire breaker with ease, and we didn't even have to take anything apart.
Let's stop testing. Any discrepancies in the set point are highlighted here. You can change your device settings back directly from this screen. Now let's generate a test report. You'll get a similar customizable cover page as all the rest of the reports. Once that's filled out, you'll be prompted to save this PDF report on your PC. Here's what it looks like. The test report provides you with all the tests you've run and the results. It also shows you set points from before you began and what they are as you leave.
I always do the same handful of tests. It would save me a lot of time if I could just set it up and save it for later.
We can do that in PXPM today. Go ahead and set up the test the way you want it. Click on Save. This brings up the test library. Give your test a name and hit Save. To use the test from the library, click on Load from the test settings screen. This takes you back to the test library to load your test. You can also delete tests and clean out your library from here if you ever want to. You can also select a test and click on Load Test to bring it up on the test parameters screen.
Let's open up the real-time data menu. Here, you can see the different values your breaker is currently experiencing. If you want the latest values, you'd want to pull that from your breaker with the Refresh button. This takes a snapshot of all the values in your breaker. Nobody wants to keep on hitting the Refresh button, so that's why we also built the Auto Refresh. Tick the box here, and PXPM will continually pull the latest values from the trip unit every second in real time.
Here are some additional functionalities you should be aware of.
First, we have single cycle waveform capture, which is included as part of the PXPM installation. Here, you can see that you have 3 phases of current, line to line and line to neutral voltages, which you can customize by turning the different channels on and off. And from here, you can capture another or export this to a PDF.
Is that the same as the PDF button on the main real-time data screen?
No, that's different. Choosing PDF report from this screen will give you the values you see on the screen. Simply fill out the data for the optional breaker installation cover sheet and save. Now that we've done that, let's look at the parameters available. The first section here gives you the trip unit's primary and secondary status. You can also see the cause of that status. Interpreting this could be a bit of a challenge, so we've included this quick reference table in our PXR manual, which is available for download at eaton.com/powerdefense.
We make periodic changes to our manuals, so be sure to check online to get the latest.
Up next, we have all of your metering type data. That's your currents, voltages, power, energy, demand, mins and maxes of currents and voltages, as well as single cycle current.
Here you will only see parameters that are available based on the feature set of your particular breaker. For instance, if you have a PXR20, which is not measuring voltage, you won't see voltages, energy, power, or demand. Those parameters will not appear. Here's another example. If you have a motor protection version of the breaker, you'll be able to see the breaker's total harmonic distortion, which is useful if you want to pinpoint a problem before you burn up a motor or a machine. In this section, we'll cover the unique breaker health and diagnostic functionalities.
Breaker health is the output of a special algorithm that provides the overall condition of your breaker based on historical data. It considers short circuits, overloads, operations, temperature, and runtime. It takes all of that into account to help you with predictive maintenance. This health monitor is a tool and not a replacement for establishing breaker maintenance or replacement practices. What Breaker Health will do is help you to better plan for maintenance and prevent problems before they cause interruptions to your operations. This makes your system more reliable and helps you to avoid unplanned downtime.
So where do we find breaker health in PXPM? I remember seeing a diagnostic section in the real-time data screen. Is that where I'd find it?
That's right. You can see the count of all the different events that have happened across the breaker's life, such as total operations, runtime, and max temperature. When you get close to the bottom of this list of parameters, you'll see the culmination of all of these various parameters put together into what is the breaker health remaining.
So, if I had a breaker for 10 years, and it says it's got 50% life remaining, does that mean it's going to last for 10 more years?
Not quite. Breaker health is calculated as a function of all of these parameters, not just runtime. Your health may have been impacted because of a high number of short-circuit trips or a high number of operations, or perhaps it was just a single high-current fault trip. But as your breaker ages, you can start to plan your maintenance. From these parameters, you can even look to see if there is some parameter that stands out as being the cause in the decrease of your breaker health. Resolving this could improve the longevity of your breaker. This goes back to the point we made earlier about not resetting the breaker's diagnostics data. When we were looking at the reset screen, we mentioned that resetting the number of operations or trips on your breaker was not recommended. If you didn't watch the device settings chapter about resetting your diagnostics data, please make sure to do so. We go through this topic in a little more depth. Basically, resetting this just deletes all the data and makes your breaker health incorrect.
When you choose Event Summaries in the PXPM, it brings up this window.
Here, you can see the recent trip events. If you select one, side pane pops out and shows all the details around the trip. These details include primary and secondary status. In this case, a long delay trip. You can also see temperature at the time of trip and the current on all three phases. All the other trip event details available from the PXR trip unit can be viewed here as well. This would be useful for troubleshooting. As you can see in this example, phase A was the cause of the trip. You cannot close this window. Let's go to the next window by hitting Next. Here you can see recent alarm events. Again, selecting one brings up side pane with details where applicable. You can also see we keep records of time adjustments too. Finally, there's a timeline of all the events that have occurred. That's everything from power-ups, time adjustments, alarms. The difference is that you can get current and historical alarms with less detail. The number of alarms you get here depends on which trip unit you've selected for your breaker. For instance, if you have a PXR 10, you get the last 10 trips and last 10 alarms. If you have a PXR 25, summary includes 200 events, and the last 10 trips and the last 10 alarms are available in detail. Like on all other screens we've seen so far, you can export these events to a PDF report.
Here, the waveform recorded button is different from the one that was covered previously with the waveform capture.
This app can be licensed and provides access to waveforms associated with the last trip or alarm that the breaker experienced. You see, when an event occurs, the trip unit will start storing pre-trip waveform cycles. The trip unit will keep on record the rest of the event and a few cycles post-trip. The number of cycles stored by the trip unit may vary. In the case of the Power Defense MCCB, for example, 6 pre-trip cycles and 4 post-trip cycles are stored. PXPM has the ability to retrieve this data from your breaker.
This level of detail would help in troubleshooting the cause of trip or cause of alarm.
Now combine that with information available in the detail view. You just have to make sure you have auxiliary voltage available to take advantage of this feature, which is important as the breaker will have a hard time recording post-trip cycles when there is no power. You can also export this to a PDF. Learn how to access the app by viewing the licensing section of this training. Even though most screens have a reports button, you may want to download all your screens at once. This section allows the user to select the specific sections desired and put them into one PDF report.
For instance, let's say you want to do a full summary of everything. You can check the Select All box and choose PDF Report. You can fill out these optional fields to customize the cover sheet and save a single file with everything.
You can also do a partial report. Let's say you want to save a report, but you only want the system status and some of the diagnostic information. You can open the section and check the boxes you want to see. In this case, status and diagnostic information, and save.
Why is test reports grayed out?
Test reports are only available for printing if you have the advanced testing license. You also have to have performed the testing during the PXPM session.
Most of what we've talked about today is unlicensed. Visit eaton.com/pxpm to download the installer for your Windows PC. There were a couple of things that were add-ons that you'd buy a license for. Select the License button on the Application Settings screen. If you've got a brand new install, you'll see something like this. You've got the licenses available, your install status, the number of usages remaining, and buttons to request a license or install a license. The licenses at the bottom are apps that we are working on but are not currently available yet. For the purposes of this training, let's look at the apps that we do have. We'll use the Advanced Testing app as an example. You see, we include 5 free sessions of each of these apps during the initial installation. As you test your breakers, you start to use up these sessions.
What's a session?
A session starts when you are connected to a breaker and you begin using one of the licensed apps. It ends when you disconnect or close PXPM. However many tests you want to run or rerun during that time counts as the same session.
So if I want to run a secondary injection test, change my set points, run another secondary injection test, and then run a sensor continuity test?
Same session. Just don't unplug the cable from your breaker, the cable from your PC, or close PXPM.
You're almost out of sessions.
Let's get some new ones. Start by clicking on the Request License button. You'll be prompted to save a file. This file gathers the information of this specific install of PXPM on this PC. Next, click on the link provided on this screen. You'll be taken to an e-commerce page for our software. You can actually purchase a lot of other products on this site too, like apps for the Power Xpert dashboard or a subscription to our cloud software, all of which pair nicely with Power Defense breakers. On the e-commerce page, select the feature you want to license. This should match the license request file you just downloaded. Select the number of sessions you'd like to purchase, and check off the acknowledgement. Then, upload your license request file. If you're somebody who does a lot of breaker testing and you're using up your sessions too quickly, you might want to consider our highest tier option, the Unlimited Sessions license, which gives you unrestricted testing for the life of your PC. It basically unlocks this feature for you, so you don't have to count anymore.
What if I want to license 2 PCs?
You would install PXPM on both PCs. Then you would save the license request file from each of the PCs separately, since each one uniquely identifies the install. Then you'd add each one to your cart separately. From here, you'd pay with a credit card, just like you would with any other shopping site, and you'll get your order confirmation right away. Within a day or so, you'll get an email from pxpmlicense@eaton.com with your license file attached. Once you have this license file, save it to your PC, and archive this email somewhere safe, just in case. If you ever have to do a clean install of Windows or something like that, you'll be able to reactivate the license on your PC. Let's go back into PXPM, Application Settings, License. Now choose Install License. Navigate to your license file and select it. You'll see that your session count has increased.
Why do I still have gray checks?
That just means that you've got sessions left. Gray means that it's a limited number. If you picked our unrestricted package, you would get a green check, and your sessions would say Infinite, and these buttons here would disappear since you'd no longer need to continue requesting licenses to use the advanced features.
We looked at the About section of this menu in an earlier session. Here's where you find your firmware version, your technical support contact, and the page to check for the latest releases. You'll definitely want to be using the latest version since we update the software and add new features all the time. Earlier, we showed how you could use PXPM to change the language of your trip unit. If you want to see that, see the video on device settings.
We can change the language of PXPM too. Under Application Settings, Language, you can find the list of available languages. Select the language you want to use and click on Update.
What if PXPM doesn't speak my language?
We'd like to see PXPM speak all languages. As new languages become available, they will be added to the new software release. This is all the more reason to make sure you still have the latest version.
Time to wrap this up. Here's what you need to know. What is PXPM?
Free software to configure and troubleshoot PXR-enabled breakers. Optional advanced apps are available for purchase at eaton.com/PXPM. Be sure to visit eaton.com/powerdefense for more videos and other resources.